Saurika. Hello everyone, thanks for joining today. I'm very excited to be with you. And in this session, I will try to share with you the experience we had in securing Kubernetes cluster. My name is Ludovic. I'm working as a CTO at NFQ. We are a software development companies, and our mission is to scale businesses. We are passionate about tech, and we like to solve business problems, whether it's to develop a software, implement a product, improve efficiency. And of course, over the last couple of years, we have been extensively working on Kubernetes platforms. We have migrated some projects, we have operating clusters, and of course, the security was one of the key aspects of our project. When we think about security, actually, it's a little bit like military castles. I had the opportunity a couple of years ago to live in Scotland, Edinburgh. It's a magnificent city. And you have this castle that is built on the top of a rock. And for more than 100 years, this castle was not breached by the England, despite many attempts to take over this castle. And when we design the security system, basically, we think about how castles and military construction has been designed. You have big walls. Usually, they are built on the top of a rock, or they are surrounded by water. And you can only access and penetrate this castle by having a single point of entry, a drone bridge that is controlling the access. So basically, with this principle, this is what we are using today when we design the security posture of our system. And when we take a step back, actually, when we think about security, we rely on two very key pillars. Usually, we do two things. We do prevention. We will try to prevent something bad from happening. We will deploy a series of measures, building walls, having water, having like this drone bridge. But we will also have detection. We want to make sure that we have guards, camera, that we have alarms that are able to identify some intrusions and then ring the bell so that someone can react. If you just have the prevention and nobody's watching, we have an issue. So today I will focus basically on the detection part because Kubernetes natively come already with a series of primitives, functionalities, features that are covering this prevention aspect, right? In Kubernetes, by default, you can use already all these primitives to secure and harden the cluster. But what about the detection? How do we make sure that we can be alerted when something bad is happening in our Kubernetes cluster? How do we do that? What kind of mechanism we want to establish so our SOC team is able to react and to detect that something bad is happening? One way we can do that is, of course, to monitor the activities that are happening on the Kubernetes cluster, right? One aspect could be to monitor the processes, to identify some weird modifications that are happening on the file systems, to identify some weird network connection, and based on these patterns, we can maybe detect some anomalies, right? If we zoom in the context of Kubernetes, what I would like to be able to do, for example, is to be alerted when some use cases that are very strange are happening, right? For those of those who are kind of manipulating production Kubernetes cluster, it seems pretty unrealistic that in a production cluster, you have suddenly someone that shell inside this container, or that someone is escalating privilege, or that suddenly an unexpected connection is happening. It's very weird. It should not happen that frequently. And it's maybe the sign that something weird is happening, and of course, we would like to be alerted, right? Another use case that we would like to track is in case you have some accounts that are created, for example, in the namespaces, or if you have some really weird role binding that's suddenly happening, or if you have, for example, a sensitive file that is mounted inside a container. All these use cases should not happen normally in a production cluster. And they might be the sign that something really, really strange is happening. As a consequences, I would like to do the same from an application perspective. I am running an Elasticsearch cluster. I am running a Kafka cluster. I know what is supposed to happen. And if suddenly I have an unexpected port that is exposed, I would like to be alerted. Again, usually we have a series of ports that is exposed by Elasticsearch, 9200 for example. If suddenly I have an unexpected port that is exposed by the service, something is really weird. Or if some sensitive file is tampered, modified, again, this is not the usual situation. So now, how we can do that? One way to do that is to use a technology called Falco. Falco is an open source project. It's been initially written in C++ and Go. It's been initially implemented by a company called Sysdig, which offer a security product. And later on, they released this open source project to the community via the CNCF. And basically, what this tool is doing, he will analyze the activity on the cluster, and he will be able to, by a set of rules, to identify some anomalies, and later on, to trigger some alerts. All right? So if we zoom in into detail, how exactly this is working. Falco is gonna listen to a series of events as an input. He will listen first to the kernel system event. I will explain later in details what it means. And he will also listen to Kubernetes audit events. Every time I do an action in Kubernetes, I am able to basically poll, listen, an audit log API that will basically allow me to assess what is happening. We have created a namespace, we have deployed a container, config map has been created, user has been edited. I can listen to all this event and process some extra logic outside of the context of Kubernetes. Falco, by listening to this event, will be able to set a couple of rules. And when we are diverging from these rules, he will be able to trigger some alerts, some outputs. It can be the standard output, can be to write everything in a file, can be to call an HTTP endpoint. We can also implement an SDK. We have different outputs that we can use to basically leverage these alerts. If we look in detail again regarding the architecture, I'm very curious about how things work underneath. Basically, the syscall that I mentioned, we need to think about what is a container, okay? A Docker container, or more generally a container, is just a software kind of like, it's a software isolation mechanism. So it means that basically we pretend that a process that executing inside a container is isolated, okay? And we do that by manipulating the Linux kernel and especially the namespaces. So it means that whenever we do an action inside a container, we are actually invoking the Linux kernel to do something, right? If I open a file inside a container, if I edit a file inside a container, if I do anything, it will result at the end with a call to the Linux kernel. And therefore, the whole strategy of Falco is to listen to these events. He can do that by having either a kernel modules or either using an eBBF prop. I can enter in detail later during the questions. And then based on that, you will be able to listen to the event that's happening on the system, on the Linux kernel. And based on these events, you will be able to trigger alerts. Okay? Another way, we can feed Falco with different kind of events. Like I mentioned, we can feed Falco with, for example, the audit log API from Kubernetes that provide a higher level of information. We can also implement our own custom sources. If tomorrow I implement my software and I am able to log some activity, I can also feed Falco with this activity on a pure business application level, right? If suddenly you have in your application a lot of accounts that are edited, destroyed, created, maybe this is a weird behavior. You are able as well to implement your own logic and to feed Falco with these logs, these rules. Okay? So how the rule is structured, basically, we can install Falco by two ways. Either we deploy it directly on the machine, right? Using a very standard approach to install packages. We will still need to make sure that all the nodes have Falco installed, or we can run Falco inside Kubernetes, and we will rely on a daemon set, right? The daemon set ensure that we have Falco running all the time. Two different approaches depending on the requirements we want. If we want to ensure an isolation between the processes and what we observe, maybe we can go with the machine. And if, for example, we want to rely on the stability of Kubernetes to kind of like make sure the process is running all the time, maybe we can use a daemon set. Two approaches, depending on the clients, we can have different expectations. When do we use Falco? What exactly do we use? We use and we submit to Falco a couple of artifacts, rules, macro, and lists. A rules is just a behavior that we want to detect that does not make any sense, and for which we want to have an alert. A macro is just a reusable condition, right? I have built a couple of conditions, I want to reuse them, I want to group them, I can create a macro. And I will have a list when I want to list a couple of aspects. So to give you an example, this is a Falco configuration file. And you have the rule, for example, that is in the bottom, terminal shell in container. It means that this rule is triggered when someone executes a shell inside a container. Okay, so I have the condition, right? The condition is a set of event systems that are triggered by Kubernetes when the container is run. I have the output, and I have a description message. Okay, and when I have built this basically condition, I am able to wrap this condition inside a macro, like the open read. So for example, the macro open read describe what is happening when a file is open. Basically, when I open a file from a syscall perspective on the Linux kernel, I have all these events that are triggered in this order. I am able as well to list basically different set of conditions, right? If I want to list all the possible shell binaries, I can just list them inside this kind of like artifact of Falco. All right? So it's interesting, but of course you will not write on your own a lot of configuration file. So of course Falco already come with a set of primitives, rules that we can already reuse for everything. What is happening when I open a file, what is happening when I rename a file, what is happening when an outgoing connection is happening, what is happening if we have suddenly a spawn process that is launched. All these conditions, they already exist, and we can basically reuse them like that. We can also, of course, do that at the application level. Like I mentioned, we know that Elasticsearch is a Java process. If suddenly in your container you have a PHP process or a Python process, your container is really like not behaving the way it's supposed to do. So you want to be alerted. You know that, for example, Elasticsearch is running on a series of like ports. If suddenly your container is exploding a new port that comes from nowhere, it smells very bad, right? So you are able to kind of like describe the condition that you can monitor as well your application based on these rules. Another way to do that, of course, it's to use existing rules, right? Again, you don't want to spend a lot of time to write all these rules, so there is also libraries in which you can pull existing rules for existing software. And all these software are very famous, popular, widely used, so you can just take the rules and use them directly. It's very nice. We can also, of course, work at the Kubernetes level. Like I mentioned, we have some Kubernetes flows, and the way to do that is to listen to what we call the Kubernetes API log. So in Kubernetes, whenever an action is happening in the cluster, I am able to listen to some events. For example, here, I have someone that is trying to list the config maps in a certain namespace. Based on this event, I will also be able to listen to this event and to trigger some rules, to trigger some alertings. So I am able to work at different levels: containers, application, Kubernetes. So an example of the rule that, for example, we can define, if suddenly we have a privileged pod that is created in a namespaces, doesn't make any sense, except if this is a kind of like technical namespace. Kubesystem, for example, you have a lot of privileged pod that are running, but it's very expected. If you have business namespaces, probably having privileged pod is really like a weird behavior. All right? So now that we have done that, we would like to broadcast these alerts, right? So far we are able to detect, but at some point, I would like to alert some people to do something or to react, right? For that, we can rely on the existing logging system that you may have already. If you're doing Kubernetes on production, you may have already FluentBit, FluentD, FluentBit, and so on. And you should already have dashboards. And because Falco is generating some alerts on the standard output, you may already have it. In case you don't have it, you can use another project, which is called Falco Sidekick. It's a very nice project because it's generic connectors to a lot of outputs. Basically, with Falco Sidekick, you can already target a Slack channel, you can already target a Teams channel, you can also target a Kafka cluster, and there is also web UI. So in case you want a very smooth integration to your system, I would highly recommend to use Falco Sidekick that is working very well with Falco. All right? Of course, when we do that, it's not enough. One aspect that we want to do is also to run some analytics regarding the security posture of the cluster. What kind of alert do we have? Where do they happen? Which user is most likely to have all these alerts? Is there any periodicity, seasonality in which these events are happening? Of course, we want to rely on our existing stuff with Elasticsearch and Kibana. So where we can group the analysis is, of course, to analyze by space, which namespace, which pod, which node, which user most likely has this kind of like alerts. In the time, by level as well, or by criticity. So it's very, very standard. It's not actually coupled to any Falco. We are just reusing standard monitoring analysis. Okay? So when we do that, of course, still it's not enough. We would like to go a little bit further, right? And one thing we would like to do is to dynamically react to an alert. Okay, this is what we did. We don't want to be spammed by like having some Slack messages or email and having a manual action required. So what we have done, we have implemented an automatic primitive inside Kubernetes. And whenever we have a weird behavior that is happening, we dynamically create a network policy attached to this container to put it in quarantine. We don't need any manual intervention. It means that based on these alerts, we are able to dynamically react. We don't need someone to be awake. We can already implement some automatic response to these alerts. Okay? So the way we've done that, we have implemented Falco, of course, and attached to Falco, we have deployed a component called Argo Events. This is the small squid that we have. When Argo event is receiving some alerts, he will directly attach a specific label to the container, to the pod, and he will dynamically create a network policy for this pod that prevents any outgoing communication. Why we are doing that? Because when we detect a weird behavior, what we want is to shut down any communication with outside of the cluster. And we want to do that for a certain amount of time, right? And basically, all of this is implemented automatically. No one is awake at 2 or 3 in the morning to do that. It's happening automatically. We have implemented different scenarios as well. We will trigger, of course, an alert in the Slack channel. Someone will have to check, what is happening with this container. And we have as well the opportunity to escalate the behavior. So far, we just put the container in quarantine. But maybe we would like to kind of like take a picture of this container by having some dump on this container so we can run some forensic later. Or maybe we want also to destroy completely this container because it has been compromised. So we are able as well to automatically implement some escalation processes based on this Argo event that is pulling event from Falco. All right? So it's very cool to play with. We need to educate a little bit the team because we may have some very weird behavior, but it's very interesting as an approach to implement active threat management. We don't have anyone to, again, having more work to analyze what is happening. Okay? So couple of recommendations if we want to implement Falco. How we did it with different clients. The first thing, we cannot deploy Falco if we don't understand where we are in terms of security posture at the Kubernetes level, right? Kubernetes is now has been used for many years, and we have a lot of legacy Kubernetes clusters. And if we just deploy Falco without understanding where we are, it's just a failure because we will have suddenly a lot of alerts. We won't understand what's going on. So at the beginning, before installing Falco, we really need to understand what is the state of the cluster. And it's even more important today that we have a couple of versions of outdated system and legacy system. And then after, what we usually do is to install Falco, but we don't do anything with it. We just deploy it, we communicate this is happening, and we will store all the alerts somewhere. But we don't block anyone, we don't implement any specific procedure, we just want to learn what is happening in the existing cluster. Is it expected that this pod is running with that? Is it expected that we have so many alerts in these namespaces? Why this Docker image is outdated? Why do we have these privileged processes? We just try to collect as much data as we want to have a picture about the state of the cluster. We will analyze these results as the phase 2, and we will run a couple of workshops with the developers so they can also understand and fix the problems. And finally, we will have this loop of reinforcement. Based on the alert in Falco, the detection part, we will implement new measure on the Kubernetes level. We will create new airbag. We will maybe implement some PSA. We will maybe implement new network policy. We will constantly use the detection to harden more the cluster. So basically, we are reusing the detection to harden, to reinforce the preventive measure. So it's really a learning process. And fortunately, by doing that, we are fixing the problem and we are reducing the likelihood that this alert is happening again. So it's really like a combination of the two processes. We have a couple of alerts. We investigate if we can fix them from the development perspective. And if we cannot fix them, we will try to reinforce the preventive measure to make sure we have fixed definitely this problem. Okay? Couple of limitations when we use Falco. Per default, we have a lot of alerts that are triggered. At the beginning, if you just install Falco on production cluster, like I mentioned, you have a lot of containers that are running in privileged aspects. It will be quite challenging. You have a second problem. When you use Falco, basically, you may have some event systems that are dropped. So basically, Falco is listening to what we call an event buffer, a ring buffer of events. And if suddenly you have many event systems that are generated on a single machine, Falco will not be able to process them and some calls will be dropped. So this is something the community is aware for many years. And of course, it's a little bit of vulnerability, right? Because if suddenly you have an attacker that is able to generate many calls, some of the calls might be dropped by Falco. So there are different strategy. We can actually solve this problem by having different strategy like throttling the calls, but this is something we need to pay attention at. When we scale as well, it starts to be very complicated. Above 400 cluster in your Kubernetes cluster, which actually is a big cluster, you may have suddenly some issues as well to manage all these events because you may have some stuff with the Falco event that is handling all what is happening. So fortunately, not everybody has this kind of like cluster size, but this is something we need to pay attention as well. And one of the last limitations we have is that, of course, as the kernel receive upgrades, we need to upgrade consequently Falco. Because if suddenly the kernel is implementing the way we launch a container in a new way, we will need to adapt Falco so it can follow up with the rules and the proper condition to trigger the alerts. All right? So a couple of recommendations, of course, if we want to move further. From the beginning, I would highly recommend to target specific namespace and container you want to watch, because it doesn't make sense trying to watch everything. I would also highly recommend to start with very limited set of rules. Some rules that don't apply, it doesn't make any sense. People don't have the skills, they're not interested. It's not a huge risk, we can drop them. And start with simple rules like, let's try first to not run a container in root. It will be already very good. And I would highly recommend as well to structure a pipeline to collect and store the alerts from the beginning. It happened in some case that, yeah, we generate a lot of alerts, but we have no Elasticsearch, we have no Kibana, we don't keep the log on a long time, and then we lose the approach because basically all the value that is generated by the data is lost. So it's a little bit annoying. So I would highly recommend to have that from the beginning. And of course, to reuse as much as possible the existing rules. Okay, so it's a couple of recommendations regarding Falco. Thank you very much for your attention, and I think we have like 1 or 2 minutes for questions. I would be very happy to take some questions if you have. Thank you very much.